Okay, I'm just moving on to question 4. It says find the series expansion for, find a series expansion for sine, of pi on 6, plus x. Okay, now this question's half in radians and it's half in degrees, which is a little bit frustrating. We could convert that directly to degrees, but look, I'll just leave everything in radians in this particular case. Now, again, like question 2, this is exercise 4D question 4, so I'll just write that here just in case. This is 4D, and this is question 4 on page 116. Okay. Now, in this case here, again, we could just use a straight Maclaurin series and make everything so much easier. However, because this is kind of in the Taylor series chapter, I'm going to approach this along the line of the Taylor series. Do you need to do this? Well, perhaps not so, but I'm going to do it this way anyway. So let's do it as if it was a Taylor series sort of situation where we say, okay, we've got g of x. I've got g of x equals to sine pi on 6 plus x. And then what I'm going to do is go g of x minus pi on 6. And as you can see, we end up with this function sine x. So you'll recognize this. This is, if you like, a Taylor series. I'm now going to construct a Taylor series about the point pi on 6. So my first step will be to go, so I'll just write, and that's f of x about a equals to pi on 6. So let me just do this. So let's do, how far have they asked it up to? Up to degree 3. So here we go. So we got f of pi on 6. Sine pi on 6 is just a half. Then I've got f dash of sine, so I'll just write this down, is cos x, and cos f dash pi on 6 is just equal to a half. Let's just run through this. F double dash x is minus sine x, so f double dash pi on 6 will equal to minus, cos, that's root 3 on 2. Root 3 on 2, and this will be minus a half. Sorry about that. F triple dash x is equal to minus cos of x. So f triple dash pi on 6 is equal to minus root 3 on 2. And I'm going to do the fourth derivative because I think we've got to do the error later. So I'll just do the fourth derivative, which gives me sine of x. Sine x, okay? So that's my fourth derivative because we'll need that for the error term just a little bit later. So straight out, we can write now our Taylor series for sine x about the point pi on 6. So we've got f of x is equal to a half, plus root 3 on 2 x minus pi on 6, minus a half, so I've got minus a half, but remember that's times 2 factorial, which is 4, and that will be x minus pi on 6 all squared, and then the last term will be minus root 3 x minus pi on 6 cubed. Can I get a little cubed in there? Yeah, I can. And that will be 2 times by 3 factorial, 6, that will be 12 on 12. Okay. Now, of course, that's f of x, which is sine x. I don't need, well, I need this one here, don't I? So I'm now going to write, really, f of pi on 6 plus x. Now, this is crazy. It seems a long way around, but I'm just doing it as a Taylor series. You can do this as a Maclaurin series, and it's actually easier, really. So I'm now going to replace x with pi on 6 plus x, which will give me a half, plus root 3 on 2x minus x squared on 4 minus x cubed. I'll just put that root in there. I'll just get rid of that. Minus root 3 x cubed on 12. And I'll just put a little red line. So, okay, so there's my series for that particular function there. And of course, f of x was sine x, so that's going to be f of pi on 6 plus x. Now, you could have done that as a Maclaurin series, and it probably would have been just as easy. Okay, so that's the first question. Hence, estimate the value of sine 35. So we can see here, x has just got to be 5 degrees, but of course that's all in radians. So I would have to change that to radians to actually estimate that. So look, I'm not going to do that. I think you can all do that. I've just got to replace x. All of these x's here just need to be replaced. Yep, they all need to be replaced with 5 degrees, but we've got to times by pi and divide by 180. Yep, so just replace that in and work out what that value is, and it's as simple as that. Okay. Or if you wanted to, you could go and put in 35 degrees here if you wanted to. Yeah, you could put in 35 degrees for that. And of course, 35 degrees minus 30 is going to get 5. So it's really up to you how you do it. Okay. Yep. So because this is for sine x, yeah, about the point pi on 6. Okay, let's move on to the next one. It says provide an upper bound for the error of your estimate. So the upper bound for the error of the estimate. So this is Lagrange, isn't it? Yeah. So what I'm going to do is I'm going to do a Taylor approach for this. Okay. So I'm going to look at a Taylor approach, which will be, I'll just see if I can shrink that bit and stick that there, just so I can get my Taylor response. So I'll just swap my pen here. I might go orange. Can I go orange? Yep. Yeah, I've got orange. So what I've got is I've got my Lagrange, which is R3 x equals to the fourth derivative, yeah, with some value c in there. And then I've got x minus pi on 6, yeah, to the power of 4. And then I've got to divide that by 4 factorial. Yep. So the fourth derivative is sine x. Now, because I'm doing a Taylor series in here about the point, so my x value can be such that it starts at pi on 6, yeah, well, or 30 degrees, and it goes all the way out to 35 degrees. So I might just write 35 degrees here. Yeah, so I've got to choose a value between there and there. Yeah. If you're doing this as a Maclaurin series, you'd have to choose a value between 0, yeah, between 0 and 5 degrees. Because I'm doing it as a Taylor, it is confusing, I know, and I apologise, but I'm going to complete this nonetheless. So when I look at sine x, okay, because that's my fourth derivative here. So my why have I got the rubber for? Now let's go back here. Dash c, I'll put the bracket there. This bit here, the fourth derivative is sine, and I need to make that a maximum. Of course, to make that a maximum, that's going to be my value c will need to be chosen between these two, and of course 35 degrees is going to be the maximum. So really it's sine of 35 degrees, which in this case will be 35, yeah, times by pi divided by 180. Yeah. And then I've got to times that by, now I need to make this as big as I possibly can. So of course I'm going to choose 35. Yeah. So 35 degrees minus 30 degrees in radians will be 5 pi on 180. And that's got to be raised to the power of 4. And then I've got to divide that by 4 and come up with what the answer is. So I'll just go to my calculator and just show you how I do that. So we'll go to the calculator here. Grab a new screen. I can just do it here. So let's go. I've got I need sine. So actually, just before I do that, though, I'll just create this. How about that? So my first one is going to be sine. And in a bracket, what have I got? That's 35, isn't it? So it's 35 times pi. A lot of work, isn't it? Yeah, divide by 180. Divide by 180, so there's that one. And then we've got to times that by 5 degrees. I'll just whack this in a bracket and put that there as well. So that will be 5 pi. 5 pi. I'm not the fastest at this. Divided by 180. I'm not sure what that G is there. 5 pi. And this will be divided by 4 factorial, which is 24. And there's our answer there. I hope that's the right answer. It doesn't seem to ring a bell, that one. Let me check it. That is 4D Q4. Let me just check. Is it right? No, it's not quite right. It's 1.39 times 10 to the power 6. Oh, gosh, Mr. Stewart, you forgot to put this in a bracket. Put that in a bracket. Can I put it in a bracket? Oh, I've got to just copy it again, sorry. So I'll copy the whole thing if I can. Control C. Sorry about that, everyone. Copy that. I've just got to put this in a bracket. That's to the power of, raise that to the power of 4. Sorry, everyone. And that's the correct answer. Okay, that makes more sense. Okay, so that's how we do that particular question. Thank you very much.